Today we're going to be working on conversion of logarithms to exponential and exponential to logarithms, which is the basic skill that we need to learn to be able to solve logarithmic expressions and logarithmic equations. Now we know that the formula for converting logarithm to exponential, let's say have logarithm of x to the base b is equal to m. The conversion formula of this function will be b raised to m equal to x. Now, in my case, I found a way on how to remember the formula visually by just looking at my logarithms. So for me, whenever I see logarithm, I see a pattern, a circular pattern, which is going or starting from the base, going to m all the way or equal to x. So I have b raised to m equal to x. So that's how I use my pattern so that I'll be able to solve logarithm conversion easily. So let's start with problem number 1. With problem number 1, I have logarithm of 36 base x equal to 2. And if I'm converting this to exponential, I'll follow the pattern. So x raised to 2 is equal to 36. So this is how I will convert my logarithmic to exponential. So for number 2 of logarithm of x base 289 equal to 1/2, if I need to change it into exponential, I'll have 289 raised to 1/2 equal to x. Or similarly, if I need to change this back to a simple equation, an exponential function of 1/2 or an exponent of 1/2 is simply square root of 289, which is the value of x. So basically, this is how we can solve logarithm by converting it into exponential and simplifying our expression, or in this case, equation. So for number 3, I have logarithm of 1 over 196 base x equals -2. Converting it, I'll have x raised to -2 equal to 1 over 196. And for my last equation, I have x equal to log of 81 base 3. Now, from the first 3 examples, I'm more used to seeing logarithm first equal to a given expression. So what I'm going to do is I'm going to rearrange my equation so that it will be a lot easier for me to convert. So I'll change it to log of 81 base 3 equal to x so that I can still use my pattern in converting my logarithm. And this is how we convert logarithm to exponential. Now let's try to convert exponential function or exponential expression into its logarithmic term. Just like conversion of log to exponents, we're going to be using the same set of formula. So if we have b raised to m equal to x, and we need to change it into an or logarithmic function, it's going to look like logarithm of x base b equal to m. Now, in this particular formula, I remember using this formula by looking at b becoming the base and then switching x and m. So for number 1, if I'm going to use that strategy, so if I have 64 raised to 1/2 equal to x, and I'm going to change it into logarithm, 64 will become smaller because it will turn into the base, and then I'll switch 1/2 and x. So I'll have x here equal to 1/2. So this is how I can complete my conversion. And I know I did it correctly because if I do my visual again, 64 raised to 1/2 is equal to x. It's the same as my exponential function from the given problem. So for number 2, I have 144 equals 12x. And this particular problem again, I'm more used to seeing the exponent on the left side equal to a real number. So I'm going to revise it or modify my equation into 12x equal to 144. And in this way, I could easily change it into logarithm by my visual. Log of base, which is 12, and then interchange 144 and x. So 144 equal to x. And for the third problem, I have x raised to negative 2 equal to 1 over 81. Converting it will be log of small and switch. So that's how I play it in my head. And for the third or the last one, I have 1 over 12 raised to 2 equal to 1 over 144. So since the exponent is on this side of the equation, I don't need to modify it. I'll have my logarithm of small and switch. And this is how we convert exponents or exponential equation into its logarithmic form.